person wrong is approaching a signal stoplight, moving with a velocity of 30 meters per second. The signal light turns yellow and wrong applies brakes and stops after a distance. If wrong's acceleration is minus 8 meters per second square, then determine the distance that wrong's car moves. This is an interesting problem which we face in every day when we travel. See, actually when you apply a brake, see, the velocity comes down, so the acceleration is negative. It is actually deceleration. That's why the negative sign. Okay. Now the question is, see how far the car moves before coming to a halt. Right. This is actually required. These calculations we do mentally. See, when we apply a brake and then want to come to a stop before the signal. Okay. Right. So let me start this. So we are given. So what are? See, we are given the initial velocity is 0 equal to 30 meters per second, and the final velocity, it comes to a stop, isn't it? So the final velocity, let me call it as Vf, it is 0. Right? And you are also given that the acceleration actually from 30 it comes to 0, so it's actually a deceleration, so that's why the negative sign is minus 8 meters per second square. And the question is, you are asked to find the distance moved. Or the displacement. Now we have to recall the corresponding equation of motion, kinematic equation of motion. See, we know that. So you are given the initial velocity, final velocity, acceleration. So we recall this. So recall Vf square equal to V naught square plus twice A into the displacement. Multiply the displacements. So here Vf, what is Vf? Vf is 0. So substituting the values, of Vf, V naught and A, we get 0 equals 30 square. So the acceleration is negative here. So 2 times 8 times D. So this gives displacement D equals 30 square by 16. Meters. That is 900 by 16. And that equals, so when you divide 5, 80, 100, 6, 42. So, see, you just have to, any problem on kinematics, you just have to recall these fundamental equations, right? See, the basic thing is you start with this differential equation, acceleration is d square s or d square s by dt square, where s is the distance traveled. So, if it is uniform acceleration, if it is a constant, say constant uniform acceleration, we are given uniform acceleration, d square is by t square equal to constant. So, a is a constant. So, if integrating, so when I integrate, v, that we call velocity at time t. So when we integrate the second derivative, we get ds by dt, that's velocity at time t, is a times t plus a constant of integration. When we substitute t equal to 0, that constant of integration should be the velocity at t equal to 0. So this is what we have. Right? So velocity at time t is the initial velocity plus at. Integrating once more, see if I integrate the velocity, I'll get the distance traveled. So the displacement is s, so vt on integration gives me s, and then t on integration is t square by 2, so half at square, and this is v naught t plus a constant of integration. And if you start the distance from t equal to 0, this will be 0. So I get s is equal to initial velocity t plus half at square. This is one equation, this is second equation. Now there are two equations involving t. So in principle you can eliminate t. So 1 and 2 give vf square equal to v naught square plus twice a es, and that's what you have used it. Will come to a halt after traveling a distance of 56.25 meters.
Thank you for watching. Visit us at needbook.in.